it. You
Uh,
know?
I think, Chris, you have to develop one module for United States Donald Trump sustainable for the world.
Step, come back a little bit. I was not getting the full picture then.
No. I think you need to prepare another model about Donald Trump making the tariff as one of the SDG for the whole world of it. Was he's making havoc in the world now.
I'm missing it. You're coming. I'm not getting every word at the moment. Harold, can you hear Srini okay or not?
Also, ad hoc, haphazardly. It does
I
not
don't
come
know
out
whether it's when
smoothly.
you. Yeah, we're not hearing every word you're saying, Srini.
No, I think my net is full.
That's fine. Now, where you are now, maybe you're getting too close and then back. Where you are now,
Yes.
your distance from the screen now, if you speak,
Is it okay now?
that's fine.
Am I audible? This is audible?
Yes.
Yes.
Yeah.
Okay.
But it's when you go very close, you disappear.
Okay. Fine.
So we don't know what you said before.
No. Forget about it.
It's okay.
I was only joking that you need to make one more module so that Donald Trump can understand what is to be done in that one.
Well, going back a second, that email you sent me, are you concerned about the
Okay. No. I will send you a mail separately on this.
It's just that Harold last night, I sent you all an email. Harold, with the connectivity, some of the slides went blurred. So we actually gave the host to operate the slides. You saw the email I sent you, Srini.
Yeah. We have now made about 5 people who are in different parts of the country are having this presentation. Because the entire in Bombay, myself, Dilip, and Ashok, we are all in the same town. If there is an internet problem, it can create anywhere. So I have sent it to Calcutta and also to Baroda, so that in case if there is anything, somebody else can step in.
Okay, so how are we going to start off? Is Harold going to? He'll run he'll handle his own slides. Is that what you decided?
At this stage, Chris, yes, I'm running the slides. So if anything goes wrong, then at least I've got a copy of the presentation as well. So then we can just change.
Okay, no issue.
Okay, that's good then.
Right now the internet is quite strong. We are not sure how it is going to play the weather, because the weather plays a very, very important role in the satellite thing. So
I'm just worried about the examination we're going to give you all at the end. Harold and I decided on a new rule. We should give all participants, particularly the organisers from India, a test at the end of it. Would that be good, Srini?
Sorry, Chris. I was busy in the other one. Tell me.
I was just saying, Harold and I, we've decided that at the end of the presentation, we give each member of the Indian Organising Committee a test.
Oh.
Is that all right?
Okay, no issue. No issue.
Come on, you should be enthusiastic. It's a very good lecture.
No, I think this is the first time that we are having something on an NDT, non-destructive. Otherwise, normally we have been having in welding and related and other subjects. This is the first time, I think, in our 3 years of WIN program, we are having one topic on NDT. Isn't it, Chris?
I see we got 9 people in already.
No, it will be there. It will be there. People will join. It is only 12 o'clock in Indian time. We have another 25 minutes for the time is there for the people to join.
So what was your final number of registrants? 190?
Yesterday night, it was somewhere around 197. And I am sure that at least 70, 80 should join, but subject to the weather conditions, and I don't know. People are not, right from morning, some of the local, the trains are not running in time, so that the people are finding it difficult to reach to their offices, provided if they can log in from their handphones. I'm not sure what is the problem. But I think we have a sizable participation should be there. At least about 60 should be there. I hope it will be normally around 60.
About 50%, so that you should get a little bit of luck and get 100. So
I hope so. But if if the weather would not have been a bad like this, then things would have been much better, because the timing is also very comfortable timing, Indian timing for the people in the office. But because of the things, people must not have reached the factories or office and other things. There's a lot of people must have taken off today and must be in home. But still, whether they have an access, I'm not sure on that one.
yeah. Okay.
Mr. Harold, I think the presentation is okay. Is it running fine for you?
Yes, we've just gone through all of the slides very, very quickly, and it's showing on that side. So I just hope
Okay.
from my side that it's not the internet is not going to dip either. So that's what happened yesterday, I think.
That's good.
Touch wood. I trust everything will go fine. Thank you very much, sir.
Fine. Do you have a video with you? No, no video clips are there involved in this presentation?
No.
No, then
No.
it is okay. As long as video is not there, then it can take care of even little variation in the internet frequency can manage it.
Okay.
Mr. Harold, what we do is that in our India is that I being the coordinator of the WIN, I just normally call the people to a meeting to order. Then we have the chairman of our the operating Indian section. He will formally introduce you to the audience, and then we will have the presentation for about 45 minutes or 1 hour. What is the time you wanted to have it?
Wow.
Yesterday's actually went over approximately an hour. So anything between 45 minutes and an hour is fine.
That is the presentation. Then after that, the discussion time, isn't it?
Fine. Yes.
Yeah, half an hour.
Okay. Okay. We will have about 1 hour presentation. Then after that, we will have the open session. Before that, we will tell the people if they have any questions, they can put it in the question and answer box. So what we will do is that after the session presentation is over, we will take up one by one of the questions. And if we still have time to have something from the audience, after we complete the checkbox question, we will ask for the people to give a thing, or otherwise we will call it as an end of it. The recording will be on, and the people, the participant will get the recording of what you are doing it. They will not be given the PPT. The PPT will not be there. Only the recordings, audio recordings will go on. That they can take it in that one. Is it okay?
One
Super, thank
question,
you.
Srini, one question. What happened yesterday when the slides became blurred, 4 or 5, 6 slides? That meant that would be on the recording as well. So what we agreed in South Africa was to ask you or Canada or New Zealand that we can use your recording to give to the people on the South African one. Otherwise, is that okay?
No problem. We can send the recording to you or to Harold, and then wherever it has to be recorded, you can send it to them. There is no issue. The topic is the same. The subject is the same, so there is no problem.
Yeah, the only thing, as I said, with the South African one, there's about 5 slides are blurred when he lost his connection. So that's why we can't use that recording in South Africa, the one we did. That's why we need to use one of the others. So if your recording is spot on, we'd like to use your recording.
Yes. We will tell him. I'll tell him, sir. 1 minute. Sachin, are you on the line? Sachin? Sachin?
Yes, I am in the line.
Sachin, after the recording is over tomorrow, what you do is that you send the recording details to Mr. Chris and to Mr. Harold. Because yesterday, I believe they had a problem in South Africa. so they were
Okay.
not able to get the full recording. So you send it one, they will circulate this to all the participants who participated yesterday in the South Africa.
Okay. I will send it.
Okay.
Thanks.
Okay, sir.
Cheers. Well done.
Okay, then Ashok आ गया क्या? Ashok का दिलीप साहब आ गया क्या?
अशोक साहब नहीं है, उसका नेट का इश्यू चल रहा है। मंगल साहब का डीवी के भी नहीं है।
दिलीप आ गया, एक मिनट। Okay.
Why is the just panelists? It says 9 participants, 4 panelists. Where does it show the list of participants?
You in the same thing, in a participant, you click the attendees. You click the link of attendees, you will be able to see the participant
Oh yeah,
list.
okay, let me see. Oh yes, thank you, I've got it. Thank you, Srini, I understood. I've seen the 5 attendees now, yeah, that's good. And then the 4 panelists. Excellent. Did you see the banner, Srini, that we came up with on improving India's national welding capability?
Yeah, I replied also to you.
Yeah, no, but have you, what's his name, Deepak? He's come up with lots of good ideas to use it throughout India.
Yes.
I'm trying to have a meeting with Luca. He's on holiday this week because I've got the whole action plan.
He's joining, I think he must have joined. He's joining on 18th, I think. 18th, he must have joined yesterday.
Who, Luca?
If I remember right, I think I read a mail that he is joining on 18th. I don't know.
No, he's gone on leave this week because I'm dealing with Rosario at the moment. So he's back next Monday. Okay,
fine.
But all I'm saying is I want to get that action plan moving. It's a very comprehensive action plan. And the banner's just one little part of it all, you know? I've had about 12, 14 people involved so far, and they like that banner. You know, they all threw their ideas in. It looks good. Totally independent it is. So that's good. So what else is news then in India, Srini, with business? Is business going well? The general business industry? Oh, he's on the phone. Talking to myself there, Harold. It's a sign of going mad, isn't it, when you start talking to yourself?
As long as you don't lose the fight when you fight with yourself, then everything is fine.
I win every time. I make sure I win every time. Well, and I don't get much chance with my wife, you see, so I've got to win sometimes. Never mind. Never mind. My soccer team got beaten last night. It was the first games of the Premier League, and we got beat 1-0. My team's Everton.
Good morning.
Morning, Dilip. How are you?
Good morning. Are we good?
Good morning, sir.
It's raining cats and dogs.
You know where that saying comes from?
I don't think so.
Well, in the old days in England, all the houses were thatched. You know, thatched roofs?
Yeah.
So people used to, you live there and used to have open fires and the smoke would go up. But the animals, because the hot air rises, they would sleep. The animals, like the dogs and cats, would sleep up on the rafters in the roof. Right? But obviously they come falling down as well. So they say it's raining cats and dogs.
All right.
Okay, good one.
The English sayings are fantastic. If you go through all the English sayings, so many of them are so good. Like a stitch in time saves 9.
Right.
So sensible.
True.
You know, and life is like that. If you go through all these sayings, I actually find that very common sense, I think is the word, for running your life. We should get every kid, the first thing at school is all those English sayings. Yeah. Anyway, how are we doing?
But
Still 15 minutes to go. We're all set up. You've run through it, haven't you, Harold? You ran through all the
Just very
slides?
quickly. Yeah, just very quickly, I ran through them. Everything is working. So yes, so we're ready and
So
willing.
they're all in the right order. Everything's in the order, no problem.
Yes.
I see. So he invites to mute me. I'm learning things all the time. Raise your hand. How do you share a screen, Srini? Delete. I don't know how to do that. How do you actually share? It says share at the bottom. So if
Yeah.
I wanted to share something with you, what would I do? I don't mean mess around with Harold. Just tell me the process.
Yeah, I guess if you share, it will be shown to everyone. It's not one-to-one sharing. So if you click on share, you will see the screens or windows which you can share.
Oh, I see. So you got all those, yeah.
So let me try. I don't know. Harold is already sharing something. So what will happen?
Oh, well, don't worry then. We don't want to mess it up.
Okay.
But it's just the one thing I've not done on these things, sharing it.
Hmm.
And the other one is the question place, Srini. You corrected me about, I said, put the question into the chat room, our chat box or chat room. But last night in South Africa, Confidence said, no, Chris, that is the name. But where do the people put their questions then? It's got chat, raise hand, share, oh, Q&A. You've got Q&A, yeah.
Yeah. Q&A is the place to put in your questions.
All right.
Chat is for just general, communication, aside from the questions.
Well, I don't think what we did last night had a Q&A on, Harold. I never noticed. Remember, I don't think there's a Q&A at the bottom, just the chat. So those questions went into the chat box, didn't they?
Yes, I think so, yes.
Was that also held on Zoom or was that a different platform?
I'm not sure.
It was actually on Teams.
Teams, yeah. Okay.
Yes.
So Teams probably
I'm
doesn't.
half Irish. I need to understand these things, otherwise I get confused easily.
Yep.
So there's your Q&A.
Teams, I don't think has another, it doesn't have anything other than chat. So
this is on the Zoom and
yeah.
the Teams, Harold, you said it was Teams, so that doesn't have a Q&A by the look of it.
Yeah.
Yeah, I've learned something today.
Yeah, it's different platforms, and the one facilitates it through chat, and the other thing, I think I'm not very au fait with Zoom, but we're using Teams quite often. Yeah.
Harold, just before you finished, right? I'm going to nip off and make myself another cup of tea.
Perfect. Sounds good.
So you see me disappear. It's not because of the lecture. It's because I have to have a cup of tea before 6 o'clock. 6 o'clock's my cut-off time for having tea.
Oh,
okay.
Those poor men have to worry about things like prostate and so on. And my doctor said, if you have tea after 6 o'clock at night, that's what gets you up during the night.
Okay.
It is. So I make sure the latest ever, 6:10. Unless my wife, of course, brings me one down, but we'll have to see.
Good afternoon, Ashok.
Good afternoon, everyone.
Hi, Ashok, how are you?
I'm good.
Hello.
Good.
I think, Ashok, you have to put off the light behind you.
Huh?
You have to put off the light behind you,
Yeah,
or you
yeah.
have to face the light.
Yeah. I know.
We are not able to see you.
Srini, just come back a little bit from the screen, just a little bit.
Yes, I'll change my direction.
Yeah.
Srini, when you spoke before, you fade a little bit.
Tell me.
Because it's very hazy outside the premises because of the heavy rains. It's very, very hazy. This is better.
Yeah, this is better.
Yeah. Now you're able to see you better.
Yeah, exactly. You're trying the slide presentation, right?
Yeah, you checked them. Mr. Harold checked it.
It's good, it's good. We have made alternate arrangements also. In case of anything goes wrong, we can start from somewhere else also, in maybe Calcutta, maybe Mumbai, to avoid the interruptions.
Thank you very much, sir.
Yeah.
Thank you.
Chris, you are talking something. What is that?
Sorry?
You were asking me something. What is that?
I was just saying, when you moved forward a little bit before, your voice dropped a little bit. You remember it was all about that distance to the screen, that's all. When you're speaking, that's all. If you come too close, your voice fades down a bit.
Okay.
That's fine. If you speak now, that distance seems about right.
Fine.
So, how's the foundation going, Ashok?
Yeah, it's going on with some activities. We'll hook up some other things also in near future. But this WIN initiative is one of the great initiatives from IIW. It's fantastic. Mr. Chris is coordinating everything throughout the world. Thanks, Chris, on this.
Well, I'm hoping with your foundation, there's lots of opportunities, I think. We just released Guidance Note 5. And the same with the document last year. If one goes through it, one can see there's lots of projects and good people around the world, like Canada. They've been doing some great projects with schools and so on, you know?
Okay.
I can just see nothing but good opportunities ahead. And when Harold speaks now, he's going to be talking about a major project in Africa that South Africa did for the last 30 years on trading people in non-destructive testing. And that's with the money from the International Atomic Energy Agency. So there's opportunities out there to get money. What won't get mentioned today is UNIDO. The South African Institute of Welding also has had a number of UNIDO projects going. So that's what I think we've got to be doing, is using Guidance Note 5 that we just released and the report we did last year on the SDGs. There's plenty of projects in there to be able to go to UNIDO and these people to get money. And especially in India, there must be fantastic opportunities there. That's the way I see it anyway. So what's our numbers now? 14.
15. I think it is about 15 now.
We always have a big rush in the last 3 minutes. Bum, 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 bum. That's a question I was going to ask you, Srini, and that. The recording, do you let everybody take the recording, anybody like in India, or only the participants?
Normally, we give it only to the participants. Sometimes, we put it in our website, IIW website, so that if anybody wants to visit and download it, they can download it in that way.
That's right.
We're not.
Because there's two different types of opinion on it. And I was going to go out to the WIM members and ask them what their ideas are. For example, South Africa, the people I'm dealing with there, they want it to only go to the participants because they're the people who took the time to attend, you see? But then you'll see other institutes where every recording is on the website, as you say. So anybody can basically download them. And of course, that helps on promoting the institute, doesn't it? You
Yes.
know,
Yeah.
as a benefit. So there's pros and cons. I think it's best on a recording to go out to everybody, because if you can get everybody in the world downloading it, you got potential for more members, more interest, and so on, you know?
Mm,
True.
that's true.
So
Anyway, I'm going to go out with an email, Srini, to the Ashok, to the members, to the WIM members, asking for their views.
Yeah, you can ask the WIN members. Everybody will send it to all of us. But we should give an incentive for the people to physically join in that, so that they can hear it much better. When hearing it, when the speaker is speaking, rather than when you're listening it after a couple of days, it makes a lot of difference.
Yeah. Well, actually, we're very close now, aren't we? 4 minutes to go, and how many have we got? 22.
22. Now,
It should
about 5 minutes, within about 4-5 minutes, we'll wait. And then by 12:30 sharp, we'll start it. 12:30, 12:32, we'll start.
How many have joined?
22, 24,
Yeah,
and now
yeah.
it is 24.
24.
अभी चढ़ेगा अभी. ये last 2 minutes में तो चक चढ़ेगा.
Yeah. Everyone wants to join at the last moment. No.
I see Mr. Vijay Agwan, who is in US, also has joined.
Okay, great.
Anyway, I will mute myself now.
Yeah.
Yeah, I think you should mute yourself, Chris. I will also mute. Now the participant is 17. The class votes of joy.
Mr. Harold, you are in Johannesburg or right now?
Close to Johannesburg, yes.
Okay.
Yes.
What's the time like over there now?
It is now almost 9 o'clock.
9 o'clock. Okay.
Yes.
Hold on, you can check that. ಇರ್ಲೇನಾ? Wait.
I think it's about 12:30. Should we start, Harold? It's about 35 people closely.
Perfect.
Chris, can we start? It's about 35 now. People will join by the time the introductions and all the things will be over. Should we?
Which is
Yeah.
Okay.
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 Very good. Good afternoon.
Okay.
Good morning. Good afternoon. Good evening to all WIN participants. We welcome you all to this 9th edition of the Welding Innovation Network Technical Series which is being coordinated by the Indian Institute of Welding from India, South African Institute of Welding from South Africa, join us by Canadian Welding Business from Canada, and then from HIRA, that is from New Zealand and Australia. We have been having a wonderful series of technical information globally being shared by most of the eminent speakers of the world, and almost about close to around 3,000 WIN members are there in the country, in the world now. They have been closely associated with the WIN program. India is hosting this on a regular basis. And I would now introduce my colleague, Mr. Ashok Malge, who is the president of the Indian Institute of Welding Foundation Division, which is holding the WIN series of lectures with us here. And we also have Mr. Dilip Kulkarni, an expert from the fabrication industry, and he is also one of the panelists along with me. And we also have Mr. Rituraj Bose, the Honorary Secretary General of the Indian Institute of Welding, will also be here. And the architect of this WIN course, Mr. Chris Smallbone from Australia, is also one of the panelists. And now I request Mr. Ashok Malge to introduce the speaker, Mr. Harold Jansen, and take over the proceedings of that one. Before we give it to you, all the participants understand. If they have any questions, kindly please put your question in the question and a box and not in the chat box. I repeat, not in the chat box, put it in the question and answer box, so that after the technical lecture is over, after the presentation is over, we will be taking about all the questions for discussion, for your clarification. And after the questions are completed, if still we have time, then with the availability of time, Oral will be able to address some of the people in case if there is any other questions from the audience of it. Thank you, ladies and gentlemen, and welcome to India today online on your participation. Mr. Ashok, thank you. Take over.
Thank you, Srini. Thank you, Srini. Good morning, good afternoon to all. It is my privilege to introduce today's speaker, Mr. Harold Jansen, an NDT consultant. Mr. Harold is qualified solid-state physicist from Pan-African University, presently known as University of Johannesburg. He joined South African Institute of Welding in 2010 and helped to establish African NDT centers as a training up. He has excellent experience in industrial sectors like power generation, petrochemical, marine, mining, and transport, and many other things. Since 2010, he held various important positions at SAIW certification as NDT examiner, system and quality manager, qualification and certification manager at the SAIW ANB. Mr. Harold was awarded the prestigious ICNDT, that's International Committee for NDT, honorary membership. This honor recognizes Mr. Harold's distinguished contributions to and activities of ICNDT. He has many more awards to his credit, and without wasting anybody's time, I now request Mr. Harold to do the presentation. Over to Mr. Harold. Mr. Harold?
Thank you, Mr. Malachi. I appreciate it. Thank you, honorable colleagues. Let's jump into the presentation. The subject of power generation in Africa, particularly when viewed from South African context, stands in marked contrast to global trends due to the continent's comparatively limited generation capacities. Currently, Africa represents approximately 3.1% of worldwide electricity demand, despite comprising nearly 19% of the global population. South Africa remains the sole African nation with an operational nuclear power facility, the Koeberg Nuclear Power Station, which provides 1,860 megawatts to its national grid, accounting for roughly 5% of the country's total electricity consumption. 15 African nations have indicated interest in developing nuclear power capabilities, with Egypt, Ghana, Kenya, Uganda, and Morocco targeting the commissioning of power generating or research reactors within the coming decade. Energy demand challenges in South Africa have been widely discussed in the media. Ongoing efforts by the South African government and Eskom have yielded notable improvements in meeting national electricity requirements and mitigating load shedding. Non-destructive testing is a critical component in addressing these obstacles, enhancing operational reliability and minimizing maintenance intervals. Nevertheless, significant capital investment remains prohibitive for certain service providers, posing difficulties regarding return on investment for inspection companies. Thus, there is a clear necessity for a platform that facilitates the introduction of advanced techniques and supports the localization of inspection expertise both within South Africa and across the broader African market. Some of the topics that we are going to consider today is the first half of the presentation is going to deal with non-destructive testing, and in the latter half of the presentation we'll look at the SIW and the industry as a whole, how they actually embrace one another and do through collaboration and networking, they actually provide service to the industry. Now, what is non-destructive testing? Non-destructive testing is the science of evaluating materials, components, or structures for flaws and property variations without causing damage. Its purpose is to ensure reliability, quality, and safety while preserving serviceability, enabling early flaw detection, life assessment, and cost-effective maintenance across critical industries such as aerospace, power, oil, gas, in our case, also nuclear power station. Just briefly, an NDT method is a broad inspection discipline and refers to the actual theoretical base of the inspection method. While a technique is a specific way that the method is actually applied. In our discussion, we're going to utilize, for example, ultrasonic testing, which has got to do with mechanical vibrations. And then the way or the technique that we're going to apply it with is, for example, either phased array or time of flight diffraction. An application is the practical use of that technique for a specific task. In other words, for example, weld inspection in power plant piping. This table represents the most widely used surface and subsurface methods. Surface methods detect discontinuities that are exposed to the material's exterior, whereas subsurface methods identify discontinuities located just beneath the surface at depths ranging up to 3 to 10 millimeters, depending on what method, technique, and frequencies are being used. Although the techniques indicated in red are considered basic applications, they may also be classified as advanced due to the specialized equipment required and the complexity involved in interpreting and evaluating the digitized data. Volumetric methods involve inspecting the entire volume of a material. Radiographic testing and ultrasonic testing are commonly employed to detect rounded, elongated, and linear indications, with detection capabilities influenced by the size, location, and orientation of discontinuities relative to the inspection medium. Additionally, alternative approaches are incorporated despite their highly specific applications. These techniques are often classified as advanced methods due to the specialized nature of the use. And here I refer to, for example, acoustic emission, guided wave technology, and later on also laser methods. Now let us consider how these methods need to be applied. An NDT code is a regulatory document establishing mandatory inspection rules. Typically, an example is the ASME code, for example. A standard defines agreed methods, practices, and acceptance criteria. For example, ISO 17640 is a good example of that. A specification details project or client-specific requirements, procedures, and parameters applying those standards to particular component or service. Quality documentation is prepared by the NDT level 3 or 2 of a specific company who converts the aforementioned requirements into comprehensive quality procedures, detailed work instructions, and report templates. What should be inspected? It is essential to take into account the specific industrial sector where each NDT inspection is conducted. Various industrial sectors may be identified, contingent upon the nation's infrastructure and its scope. For example, in South Africa, we've got power generation, we've got petrochemical, we've got transport, and then we've got also a bunch of other industrial sectors such as mining, defense, food and beverage, etc. as well. This presentation will center on the power generation sector. Within this industry, there are three primary subsectors. Conventional, in this case, I'm referring to coal-fired power stations. Then we're also looking at nuclear, and then also at renewable energy sources. Components within the power generation sector undergo a life cycle that includes, every industrial sector comprises of several components that require inspection. These components are produced using diverse manufacturing methods, and because discontinuities may be associated with a specific manufacturing process, different product sectors can be identified. In this case, I'm referring to product sectors that's typically defined in ISO 9712, which is the international standard relating to qualification and certification of personnel. And in here, we've got, for example, castings, forgings, and welds, either in ferrous or non-ferrous materials. We're looking at tubes and pipes. Tubes specifically under eddy current inspection, and then we're also looking at rod products. Then when you're looking at composite materials there at the bottom, for example, cement matrix composites, reinforced plastics, etc. So these are the product sectors based on the manufacturing process. Components within the power generation sector undergo a life cycle that includes manufacturing, installation, and a period of operation before in-service inspections become necessary. The specific nature of each piece of equipment, its usage patterns, and the operating conditions to which it is subjected can result in development of various service-related discontinuities over time. Consequently, while industrial and product sectors are defined at the project outset, it is essential to also consider the individual characteristics of the components used within each industrial sector when selecting appropriate NDT methods and techniques. The allocation of inspection methods must account for the unique challenges and discontinuity types that may arise due to service conditions. The power generation sector contains a range of components that must be accounted for when establishing an effective in-service inspection program. Each of these components present distinct considerations for inspection planning, ensuring the service-related discontinuities can be reliably identified and addressed throughout the operational life. Typical components consist of steam turbines, gas turbines, generators, boilers, and then also heat exchangers. In addition to those, we've got pressure vessels, we've got condensers, we've got piping systems, and then we've also got support structures and control valves. Now, on the right-hand side of this list, you'll see, for example, the typical non-destructive testing methods that is used, from left being the preferred method up to right, which is the lesser preferred method. But all of these methods are actually employed to inspect these components during the maintenance windows. Power generation in South Africa has adopted a standard approach, especially when considering advanced techniques, whereby procedures need to be qualified before being used on site. Procedure qualification generally follows the NDT reliability studies methodology as defined in ISO 18743. and are structured quantitative investigations designed to evaluate and demonstrate the capability of specific non-destructive testing methods, procedures, equipment configuration, and operators to detect, characterize, and size discontinuities under defined conditions. The purpose of this study is to measure the true effectiveness of an NDT system beyond theoretical capabilities. Key metrics in the NDT reliability studies are probability of detection, which refers to the likelihood that a flaw of a given size will be detected, the false call rate, which is a proportion of the reported indications that are not actually defects, sizing accuracy, in other words, difference between measured and actual flaw size, and then lastly, the repeatability and the reproducibility, which relates to the consistency of the results between repeated inspections by the same or different operators. The following two closely related ISO standards are easily confused. ISO 18743, which has just been mentioned, defines the process for evaluating NDT reliability, including a probability of detection and statistical confidence demonstration. ISO TS 11774 outlines performance-based qualification, ensuring procedures, equipment, and personnel can achieve required inspection outcomes. Simply put, ISO 18743 quantifies reliability statistically, while ISO 11774 qualifies the overall NDT system performance in practice. No matter how sophisticated the non-destructive testing technique is, it can yield ineffective results if not performed correctly. In non-destructive testing, the probability of detection is a quantitative measure of an inspection system's capability to reliably detect a flaw of a given size, type, and location under defined conditions. This table presents the standard probability of detection observed under laboratory conditions across multiple product sectors. These product sectors being castings, forgings, and welds, and in general, these are only ferrous materials that is being mentioned. The data is derived from qualification assessments and a verification of test samples containing known discontinuities. In this case, for example, you can see that under eddy current testing, which is an electromagnetic testing technique, you've got a probability of detection of 50 to 80% for castings, going up to 70 to 90% in welds, and is very sensitive for surface and near surface indications, but only in conductive materials due to the nature of the principles of eddy current method. Real applications typically yield a 10 to 20% lower probability of detection, with the following factors influencing the outcomes thereof. We're looking at the method capability, in other words, specifically with regards to eddy current and radiographic testing. In other words, what is it actually capable of detecting? We're looking at the inspection parameters, in other words, frequencies, sensitivity settings, exposure conditions, etc. We're looking at the operator competence. We're looking at the component geometry and material properties, and then we're also looking at the flaw morphology and orientation. For example, the surface finish and geometry of the particular component greatly affects, for example, the eddy current and the penetrant testing results, while the grain structure influences, for example, the magnetic particle testing results as well. This slide shows the typical probability of detection for surface and subsurface methods. And in here, for example, you see, for example, we've got two key points, which is the one is the false call rate, which is the proportion of the reported indications that are not actual defects when verified by a validated reference method. And we're also looking at the A9095 flaw size criteria when looking at probability of detection. And this actually represents the smallest flaw that the combination of inspection method, procedure, equipment, and operator can detect with at least a 90% probability with a 95% statistical confidence in this assessment. These are all surface or subsurface flows, referring to eddy current testing, for example. And then we're looking, for example, at typical probability of detection for volumetric methods, which actually includes some of the advanced methods. In other words, we're looking at phased array, we're looking at time of flight diffraction, and we're also looking at radiographic testing, which includes both film as well as digital applications. So in other words, there, for example, you can see that you've got a typical probability of detection for phased array from 1 to 2 millimeter planar floors, and you've got a 3 to 8% false call rate, for example. Advanced non-destructive testing techniques are enhanced technologies and data analysis to provide higher sensitivity, accuracy, and insight than conventional NDT. Techniques like phased array ultrasonics, digital radiography, and drone technology enable detailed characterization, 3D imaging, and remote inspections, improving flaw detection, structural assessment, and predictive maintenance capabilities. We are going to briefly discuss the following advanced techniques. I have mentioned at the beginning, for example, that we're looking at a platform to actually introduce these techniques on a broader front into the industry. And that's why we're actually focusing on these specific methods, because that is the process that we are planning to actually roll out the platform, which I'll give more information later on. Ultrasonic phased array is an advanced ultrasonic inspection technique that uses multiple small ultrasonic transducer elements, each individually pulsed and time delayed by a computer-controlled instrument. By manipulating the time of these pulses, the ultrasonic beam can be electronically steered, focused, and swept through the test material without physically moving the probe. This enables the generation of multiple inspection angles, focal depths, and scan patterns from a single probe position. Typical applications is, for example, weld inspections, nozzle and complex geometries, and then also, for example, for corrosion mapping. Some of the detection capabilities offer advantages over conventional single element ultrasonic testing. We have mentioned, for example, the multi-angle coverage, in which a single phased array probe can inspect at various angles, improving the probability of detection for flaws with different orientations. Furthermore, the electronic focusing optimizes sensitivity at specific depths, enhancing resolution and signal to noise ratio. Imaging, in other words, the results can be displayed in real-time S scans, which is a sectorial scan, cross-sectional scans or B scans, and a plan view or C scans, aiding flaw characterization and reporting. The data recording of phased array ultrasonics facilitates full data storage for review, traceability, as well as auditing purposes. Some of the challenges that needs to be considered: the complexity of the instrument itself. So in other words, the instrument setup, focal law calculation, and scan plan development require highly trained personnel, whereas the incorrect setup can result in missed or mischaracterized indications. Obviously, the cost of the equipment and the probes are more expensive than conventional UT, potentially limiting the use for small-scale applications. Calibration and validation, reference blocks with representative geometry and defects are essential for accurate sensitivity calibration and procedure qualification. And then lastly, the data interpretation provides also with a challenge. While imaging assists evaluation, interpretation still relies heavily on the operator expertise to distinguish relevant flaws from geometry or noise. Phased array ultrasonic testing for in-service examination of butt electrofusion joints in large diameter HDPE or high density polyethylene, cooling water, and safety related piping is a typical application of ultrasonic phased array testing. In modern nuclear power plants, high-density polyethylene piping is increasingly used for buried or submerged service in essential cooling water systems and other safety-related fluid transport lines due to its corrosion resistance, low weight, and long-term durability. The primary integrity concern in HDPE systems is the weld joint quality. Defects such as cold fusion, lack of fusion, inclusions, and voids can compromise safety margins. Conventional UT methods struggle in HDPE due to the following reasons. In other words, the material has got a very high attenuation and consequently can actually scatter the electronic or the sound pulse. It's got a lower sound velocity, in other words, 2,200 meters per second approximately, mode conversion in anisotropic fusion zones, and complex geometry of fusion interfaces. UT phased array, especially when combined with low frequency, large aperture probes and custom delay law designs, enables high resolution volumetric inspection of HDPE welds in compliance with codes such as ASME code case N755. Now, courtesy of Dr. Colin Bird from CRB Inspections, the following was actually provided the following setup, and then also typically a result of one of these welds that was inspected in an 800 millimeter diameter pipe with the wall thickness of 25 millimeter of a HDPE electron fusion butt weld in a pipeline. The resolution that you can see, for example, you'll see two images at the bottom. The one with the dots that actually shows the fusion line with the heat wires, and each one of those heat wires is typically 1 millimeter thick, and then the spacing between each one of these wires is also a millimeter. And you can also see, for example, the lack of fusion and also the heat zone that you can notice in that area. And at the bottom, you can see, for example, a typical image of a weld that has got a lack of fusion as well. Eskom has initiated a considerable effort to optimize boiler tube inspections by transitioning from radiographic testing to small bore phased array ultrasonic inspections while maintaining safety standards. Zwane Inspections is among the organizations that have successfully adopted this advanced inspection technique. There's a brief overview. Small bore boiler tubes in conventional power boilers are exposed to severe cyclic thermal and pressure stresses, as well as aggressive flue gas chemistry. Common degradation modes include corrosion fatigue, hydrogen damage such as hydrogen-induced cracking, caustic gouging, pitting, and wall thinning from erosion and corrosion. Traditional single element UT and RT have limitations on small diameter tubes due to restricted access in congested tube banks, complex curvature leading to beam distortion and coupling issues, as well as time-consuming single angle scanning for full coverage. Ultrasonic phased array overcomes these challenges by electronically steering and focusing the ultrasonic beam, enabling multi-angle inspection from a single probe position with rapid data acquisition and real-time imaging. Detect unit inspection utilizes a flexible array probe equipped with customized holders to identify a 0.5 millimeter wall loss in pitting corrosion of 2 millimeter diameter and bigger. Real-time data review is conducted to ensure that only accurate and accessible information is collected for subsequent analysis and reporting. Some of the benefits to the power generation sector with regards to ultrasonic of small bore boiler tubes is the rapid full coverage inspection, the high probability of detection for small misorientated cracks, the permanent digital records for risk-based inspection programs, as well as the reduced outage time compared to the manual UT point measurement or the RT film processing. Integrity NDT employs an ultrabot, which is actually shown in this picture, or this central picture, to conduct remote inspections in areas that are challenging to access, thereby eliminating the need for scaffolding. TUV Soot South Africa, which is also one of the local service providers, compares here, for example, the effect of ultrasonic phased array in comparison to radiographic testing. And one of the biggest advantages that you can see there, right at the bottom, is the fewer personnel required per team when you actually compare the ultrasonic phased array team to, for example, the radiographic team. So that's one of the advantages, for example. Ultrasonic time of flight diffraction is an advanced ultrasonic inspection technique primarily used for detection and sizing of planar defects such as cracks and lack of fusion in welds. Unlike conventional pulse echo methods that rely on reflected beam amplitudes, TOFT exploits the diffraction of ultrasonic waves from the tips of defects. The standard setup uses two probes placed on opposite sides of the weld. One acts as a transmitter, the other as a receiver, both coupled to the surface. The transmitter emits a longitudinal ultrasonic pulse that travels through the material, and the receiver captures signals from three main sources. Firstly, the lateral wave, which is a direct sound traveling along the surface, the backwall reflection, each echo from the far surface, and then the diffracted signal emitted from the upper and the lower tips of the floors. By measuring the time of flight between the transmitted pulse and the diffracted signals, the system can accurately locate and size the defect. TOFT's floor sizing accuracy is generally independent of the defect orientation, making it a highly reliable volumetric inspection method. Some of the detection capabilities, in other words, you've got a high sizing accuracy, so the tip diffraction signals allow through thickness sizing, typically within 1 millimeter accuracy under favorable conditions. The orientation, we've already mentioned that the detection and the sizing are largely unaffected by the defect tilt or skew, unlike shear wave ultrasonic testing. And then the full coverage, a single beam can inspect the complete weld cross-section, reducing the need for multiple angle setups. Some of the challenges and limitations that might exist: near surface dead zone, and due to the proximity of lateral wave and tip diffracted signals, defects close to the scanning surface may be obscured. Complementary UT angles are often needed. The signal interpretation: although TOFT produces a clear B-scan image, accurate interpretation and sizing require trained and experienced operators. TOFT is highly sensitive to through thickness cracks, but less effective at detecting very small volumetric flaws such as porosity. And then lastly, the surface condition and coupling. As with all UT methods, smooth, well-prepared surfaces improve the signal reliability. Digital radiography testing is a modern adaptation of traditional radiography, replacing film with digital image acquisition and processing systems. The fundamental principle remains the same. In other words, X-rays or gamma rays are directed through the test object, and the transmitted radiation is captured to produce an image that reveals internal features based on variations in the material thickness, density, as well as composition. In digital RT, instead of the film, the image is captured using one of several detector technologies. Firstly, computed radiography uses phosphor imaging plates scanned by a laser to produce a digital image. Direct digital radiography employs a flat panel detector or a charged couple device for real-time image capturing, while computed tomography or CT uses multiple radiographic images from different angles to reconstruct a 3D representation of the object. Digital acquisition allows immediate image processing, storage, and remote transfer without the need for chemical film development. Some of the detection capabilities. The key strengths of digital radiography includes the high image quality. In other words, the digital systems can produce images with fine resolution and high contrast sensitivity. The digital tools also allow for zooming, filtering, contrast adjustment, and defect measurement without rescanning. So that refers to the image enhancement And then also the dose optimization. In other words, digital detectors often require less radiation exposure than film for equivalent image quality, hence actually improving the safety of the inspection process itself. Challenges and limitation. Again, the initial investment of the digital detectors, scanners, and software can be costly, especially for high-resolution flat panel systems. The detector limitations, in other words, the physical size, resolution, and radiation sensitivity may vary. Some systems are less effective for very thick or dense materials. And then also archiving and compatibility of the actual digital data. The long-term digital storage must ensure file integrity and compatibility with evolving software and formats. And very often it actually results that your software might be out of date, and then consequently you might struggle with actually access or having access to the archived images that was stored. So those are some of the challenges that occur within digital radiography. Phased array eddy current is based on electromagnetic induction, and alternating current passes through multiple coils in the probe, generating localized oscillating magnetic fields. When the probe is brought near an electrical conductive material, these fields induce eddy currents in the test piece. Disruptions in eddy current flow caused by surface or near surface flaws, material property variations, or geometric changes affect the measurement, the measured impedance of that coil. Unlike single coil eddy current, phased array eddy current probes contain an array of coils whose excitation can be electronically phased. This allows the system to steer and focus the eddy current field, very similar to phased array ultrasonics. The result is rapid multiplex scanning with improved resolution and customizable inspection coverage, which is typically used to inspect turbine blades in power generation, rotor bores, and conductive tubing for cracks, wear, or corrosion. Some of the detection capabilities of eddy current phased array is sub-millimeter surface and near-surface crack identification in conductive alloys. Then also the electronic steering minimizes lift-off effects and enhances flaw discrimination in challenging geometries. The frequency selection and probe configuration can be tailored to optimize penetration depth or resolution for specific applications. Some of the challenges that might arise, similar to, for example, normal eddy current, the conductivity and the permeability has a significant influence on the result. Non-conductive materials cannot be inspected, and ferromagnetic components may require a demagnetization or specialized probes to actually remove the influence or limit the influence of the permeability changes within the material. Depth limitation, like conventional eddy current testing, the phased array eddy current testing is most effective for surface and near surface defects with deeper flaws that may go undetected. The higher the frequency, the lower the depth of penetration. That's a normal practice. Cost and complexity, the systems and probes are more expensive than conventional eddy current testing and require a specialized operating trainer or training. You will notice that the reference with regards to cost is a constant factor throughout, for example, the advanced testing methods. Remote visual testing. Remote visual testing is a non-destructive testing method that employs optical instruments to visually assess the conditions of a component or structures that are inaccessible or hazardous to approach directly. When integrated with a drone, or also referred to as an unmanned aerial vehicle, digital radiography gains enhanced mobility, reach, as well as efficiency. Modern inspection drones are equipped with high-resolution cameras, optical zoom, and in some cases, thermal imaging or LIDAR and multispectral sensors. LIDAR actually stands for light detection and ranging, and is a remote sensing technology that uses laser light to measure distances and create detailed 3D models of objects as well as landscapes. The drone serves as a mobile platform, maneuvering to capture still images, video and real-time visual data from safe standoff distances. Live feeds are transmitted to the inspector while who evaluates surface condition, detects discontinuities, and documents findings without direct human exposure to confined space, heights, or hazardous environments. Some of the challenges of drone technology or remote visual technology is, firstly, the resolution versus distance. Image clarity drops with distance. Close approaches may be limited by the geometry, even by factors such as wind or even safety constraints. The surface access limitations, in other words, remote digital testing detects only surface visible indications, while subsurface floors requires complementary NDT methods. So it's got exactly the same limitations as normal visual testing. The only advantage is, for example, you've got remote access to it. The battery life, in other words, typical flight durations range from 20 to 40 minutes, requiring careful mission planning. Sometimes you've got navigational constraints. In other words, GPS might be denied in certain environments, and that requires advanced positioning systems or manual piloting skills to actually gain access to those areas. Then also operator qualification. In other words, in general, the operator actually requires not only the knowledge with regards to NDT, but he also needs to be registered as a UAV or unmanned aviation vehicle pilot with the relevant authority. So in South Africa, for example, the operator must hold a remote pilot license and be registered with the South African Civil Aviation Authority as well. Gammatech, in partnership with Flyability, stands among the foremost providers of drone technology solutions. And here you can see, for example, 2 images of their drones that can be either be used, for example, for visual testing, but also, for example, for ultrasonic wall thickness measurement. In other words, remote testing ability while using the drone technology itself. Laser-based methods applied within the South African industry has been limited to internal tube measurement, in other words, laser profilometry, and then limited chirography applications. The list of laser methods that's detailed in this slide, as well as the next slide, emphasizes the need for a platform to introduce new and advanced methods and techniques within the local industry. Some of these equipment and capabilities are not very cost effective, especially for small service providers, and consequently a suitable platform is required whereby you can actually introduce this to the market and then provide training, for example, to localized personnel that can actually roll out some of these facilities to maybe those end users that's actually interested in actually utilizing these methods. And what is the rationale for adopting a new approach? We've mentioned, for example, all of the advanced techniques up to now, but similar to, for example, to non-destructive testing, you normally get, for example, an image of a component or a product at a certain time. But now, for example, the approach that's being adopted is to actually try to prevent, for example, future failures and to do maintenance planning as well. So we need to have a look at a different rationale or approach with regards to the utilization of advanced technology. So in other words, what is the rationale? In other words, number one, we've got a growing energy requirements. Specifically in South Africa, the energy demand is consistently increasing. We've got increased design complexities. I was looking at the small modular reactors, for example. So in other words, small already refers to a very, very critical design and very often very difficult to get to the areas that you need to inspect. Shortened maintenance periods, large-scale data acquisition. So all of these digital recordings that has been made actually results in very, very high and dense digital data, which needs to be actually then controlled and actually utilized. And then also we're looking at ultimately enhanced reliability expectations. So in other words, always we need to find the flaws that is difficult to find and that can actually lead to dramatic failure. So in other words, we've got an enhanced reliability expectation as well. So we need to have a different adaptation or a process that we can actually follow. Now, NDT 4.0 is the application of digital transformation and cyber physical systems in non-destructive testing processes. So the objective of NDT 4.0 is to enhance inspection quality, to reduce human error, and improve data analysis. By leveraging automation, connectivity, and intelligent systems, NDT 4.0 aims to provide real-time insights and predictive maintenance capabilities, ensuring greater safety and efficiency. South Africa is very much on the early stages in the adoption of the NDT 4.0 technologies, even though some of the actual data analysis is being done off-site, and then also the use of robotics is increasingly being used in the industry as well. Now, some of the key components of NDT 4.0 is the digitization and data management. So the central to the NDT 4.0 is the digitization of inspection data. Digital tools allow for the storage, retrieval, and sharing of vast amounts of test data, which can be used for trend analysis, quality tracking, as well as regulatory compliance. Automated NDT systems and robotics reduce the need for manual intervention in hazardous environments. We've already mentioned drones. Crawlers and robotic arms can perform inspections in confined or dangerous areas, increasing safety and consistency. Artificial intelligence or machine learning algorithms are used to analyze large data sets from inspections, detect anomalies, and predict failures. This allows for early detection of flaws and supports predictive maintenance strategies. Highly important and critical, however, is still to have the input of a properly qualified operator or technician to actually evaluate those data and to interpret it in accordance to the actual operating conditions. So that actually ends off our bit with regards to the advanced NDT methods. And now we're going to start focusing on SIW and the industry. And we are going to look at starting at the historic proven track record of, in this case, SIW at the onset. So from 1980 to currently, SIW, or Southern African Institute of Welding, they have actually been training NDT technicians in 6 methods, in the 6 basic methods, up to 3 qualification levels. In other words, according to ISO 9712, you've got level 1, level 2, level 3, each one with a unique responsibilities and actions that they need to take. We've also covering, for example, product sectors, all of these are being ferrous materials. So I was looking at casting, forgings, and welds. And then under industrial sector, pre and in-service testing. So in other words, while we've got different sectors within the country, with regards to NDT, we found that this industrial sector actually covers most of the applications that is required. Since 1980, more than 12,000 students have actually been trained in various techniques. So in other words, that is the track record for training. Examination, on the other hand, annually, an average of 1,200 NDT examinations are performed, ranging from initial, transition, as well as recertification examinations across the board. And if you actually compare all of the averages, you can see that the average of the NDT examinations are between 50 to 60% throughout all of the actual methods and all of the levels as well. Close to 6,000 personnel certificates have been issued since the ISO 9712 standard was adopted at SIW in 2005. According to ISO 9712, it defines qualification as a process where a non-destructive testing professional gains the required knowledge, skills, and experience in specific NDT methods. Competence is assessed through written and practical examinations by an accredited third-party certification body. After meeting all requirements and verifying competence, a certificate is then issued. Certification serves as a formal recognition of an individual's general competence within a particular NDT method and at a specific qualification level. This certification must be conferred by an independent accredited body, centralized and not affiliated with the employer. To maintain impartiality and reliability, these certifying organizations are required to hold accreditation in accordance with ISO IEC 17024. The United Nations Sustainable Development Goals establish 17 key global objectives to be achieved by 2030. These include eradicating poverty and hunger, promoting health and well-being, ensuring inclusive and equitable education, achieving gender equality, providing access to clean water and affordable energy, supporting economic growth and innovation, reducing inequalities, advancing sustainable urban development, addressing climate change, protecting terrestrial and marine ecosystems, upholding peace and justice, and strengthening international partnerships with sustainable development. The International Atomic Energy Agency is an autonomous body within the UN family, created to promote safe and peaceful use of nuclear energy. It supports the UN strategic goals, reports to the General Assembly and Security Council, and acts as the global watchdog, ensuring nuclear materials are not diverted for the use of weapons. Although the UN and the IAEA are both committed to achieving the following Sustainable Development Goals, in other words, eradicating poverty and hunger, promoting health and well-being, and ensuring access to clean water and affordable energy, substantial advancements have been accomplished within the remaining areas through the development of national NDT capabilities. And in here, for example, you can see some of the areas that has been addressed throughout the training as well. Please just keep in mind that the statistics that you will see with regards to the gender as well as the ethnicity is based on all of the students that has been trained since 1980. So in other words, it is not per year, but it actually takes into consideration the overall number of students. In other words, that's why in the last few years, that has changed significantly, but if you reflect it over the entire period, then, for example, that is currently the values that you actually see from those results. The International Atomic Energy Agency enhances regional nuclear science and technology capabilities by establishing regional designated centers. These centers are pivotal in strengthening expertise across specific technical domains, including non-destructive testing. Within Africa, 3 RDCs focus on non-destructive testing. Firstly, in South Africa, the SIW, then we're looking at Tunisia, SATIM, and then we're also looking at Morocco, SNESTEN, with regards to the RDCs. SIW has achieved notable successes as the Anglophone, the regional designation center for NDT in Africa. And the fellowship program's participants now hold leadership roles in national NDT industries. So throughout that period, 183 NDT personnel was directly trained in 5 methods, and these personnel actually originated from 18 English-speaking countries within South Africa. Since October 2011, expert workshops was actually presented at SIW, and then also 14 scientific missions were conducted by SIW personnel in other countries, for example. 3 approved training bodies, 1 in Cameroon, Kenya, and Sudan, was established during this period as well. Now we're looking at the current situation. In other words, we're looking at adapting, how we can adapt to change. Similar to across, I suppose, globally, there's an ever-changing legislation and requirements of government. So in other words, numerous government departments have NDT-related interests, and evolving requirements for cooperation and regulatory changes necessitate the ongoing compliance from NDT industry within the statutory framework. So within South Africa, for example, we've got the Department of Labour that actually determines the safety issues. Then we're looking at the Department of Trade and Industry and Competition. They are actually then looking at the national accreditation system under SANAS. We also need to comply, for example, with the Department of Health with regards to products that actually, like, for example, radiographic or radiation material that needs to be controlled. Then we also need to comply, for example, to the Basic Education Department as well as the Higher Education Department with regards to the National Qualifications Framework, under which there's a few quality councils. And then we're also looking at, for example, the South African Department of Science and Innovation, as well as the Mineral Resources and Energy. So in other words, all of these governmental departments has actually got an interest within the NDT, and they've got various actions or implementation that they actually require to be adhered to by the NDT industry per se. Now, under the changing regulatory environment, the Department of Labour enforces the Occupational Health and Safety Act, under which the pressure equipment regulations, very similar to the PED in Europe, require only competent registered practitioners to work on gas and pressure systems. The South African Qualification and Certification Committee, or the SAQCC, they are authorized by the Department of Labour to certify and register practitioners to ensure compliance. Now, within the SIW, we've got three long-standing systems. In other words, the one actually the SAQCC competent person, focusing on pressure vessels and steam generators. And in each case, for example, you've got 1,100 inspectors. And then on a steam generator, you've got, for example, 300 registered personnel that's actually performing those functions. Then there is a new advance, in other words, where they're also looking to introduce nuclear inspections under the SAQCC window, and that forms actually part of this entire process, whereby you're going to focus on the nuclear industry as well. And then SAQCC NDT, the original term, was actually originated by SIW in 1984. That has also been required to be established in line with the governmental requirements. And then lastly, we've got the Inspector of Pressurized Equipment. Approximately 600 personnel has already been identified or registered under that. And these are then the regulatory environment within which the actual personnel needs to operate. Similar to, for example, to the NDT 4.0, the advances in the progress within industry requires that we need to start collaborating and networking with actually other partners that's also in the industry. And very often, some of these partners are competition, but it is essential, for example, for the health of non-destructive testing that a healthy collaboration between these parties actually exists, so that the competence and the capabilities of the NDT is actually harmonized within the actual national system. So in this case, for example, we've got the National NDT Society, in other words, South African Institute of Non-Destructive Testing, or also abbreviated as SAINT. They promote awareness, collaboration and networking of NDT within the national and regional African context. Then we're looking at the NDT training schools. In response to the growing national demand, several specialized NDT training institutions have been established in South Africa, including the SIW, Southern African Institute of Welding. Then we're also looking at the African NDT Center. We're looking at Non-Destructive Academy of South Africa, also referred to as SANDI. Then also NASA. And then we're also looking at School for Applied Non-Destructive Testing Examination. That is SANDI, and then also IQS International. So in other words, we've got a number of training schools in South Africa, and these schools provide quality NDT training that is recognized both nationally as well as internationally. And just a quick reminder, NDT training is practical hands-on instruction focused on specific methods, techniques, and equipment to achieve operational competence and certification, while NDT education is a broader concept covering theoretical principles, material science, physics, and inspection fundamentals. Education builds underlying knowledge while training develops applied skills needed for procedure execution, compliance, and industry qualification. Now, the Vaal University of Technology has established NQF, or National Qualification Framework, Level 6 and 7 programs in non-destructive testing, including both diploma and advanced diploma options. The institution is actively working towards expanding these offerings to encompass qualifications up to NQF Level 10. South Africa's National Qualifications Framework comprises of 10 levels, ranging from foundational education and skills at Level 1 through to doctoral degrees at Level 10. Then we're also looking at NDT certification bodies. Alignment of competence standards among all the ISO IEC 17024 personnel certification bodies operating nationally, and in South Africa we've got effectively three, potentially four operating personnel certification bodies. First of all, SRW, then we're looking at PCN, we've also got CSWIP, and then we've also got the upcoming SANDI, and they're currently in the process of actually being recognized internationally as well. Now, a national project has been initiated to enhance the national capabilities with an emphasis on UT phased array as UT TOFT, and the period for this national project is from 2024 to 2026. Now, the objective of this AIEA supported project is to establish comprehensive UT phased array and TOFT training, research, and service capabilities within the national nuclear industry. This will be achieved through the facilitation of instructor qualification, training, and certification processes, supported by the provision of essential equipment infrastructure. 2 Level 1 and Level 2 training sessions in UT phased array and TOFT have been organized, featuring international experts as facilitators. The initial session will be conducted at SRW, followed by a second session hosted at newly established Nuclear School of Excellence. These training programs are designed not only to equip participants with the necessary knowledge, comprehension, and practical skills, but also to foster advanced analytical, evaluative, and creative abilities within these specialized ultrasonic techniques. A memorandum of understanding was signed between NEXA and SRW in 2022 to enhance industrial collaboration and ongoing sponsorship in support of the development of a School of Excellence, specializing in advanced non-destructive testing and nuclear testing applications. The primary objective of this facility is to establish advanced NDT capabilities within South Africa, with a particular focus on the nuclear sector. So we initially indicated, for example, that platform is required to roll this out, and the intent of this Nuclear School of Excellence is actually to provide exactly that platform. While initial activities are concentrated on ultrasonic phased array and time of flight, further initiatives are underway to expand into digital radiography, electromagnetic testing, leak testing, as well as thermographic testing. The purpose of this facility, therefore, is to establish a platform for introducing and localization of qualified personnel, thereby equipping both national and African industries with advanced NDT capabilities. The African Federation of Non-Destructive Testing unites Africa's national NDT societies, fostering collaboration, harmonization of standards, and professional development across the continent. It represents Africa within the International Committee for Non-Destructive Testing, or ICNDT, and it supports certification and training initiatives, promotes research, and advances in inspection and reliability for safety-critical industries, infrastructure integrity, and sustainable continental growth. The goal for the next 10 years, starting from 2026 to 2036, is to develop national NDT training centers and establish ICNDT recognized certification organizations across 49 African countries. Each facility will adhere to international standards and engage in IAEA technical cooperation programs. Please allow me to formally acknowledge the following South African companies and entities for their valuable contribution to this presentation. And I sincerely appreciate the collective efforts of the local industry. Steve Jobs, he has mentioned that innovation is the ability to see change as an opportunity and not a threat. And this is actually an invitation to all to see, for example, all of these changes with regards to advanced methods, as well as the introduction of NDT 4.0 as an opportunity for growth and increased reliability within the NDT field. I thank you very much for your time and for your listening.
Thank you, Mr. Harold, and it was a very good lecture and very interesting. And it gave overview for a lot of people about what is NDT and what are the techniques and how it has to be used in this one. So now I would request our panelist, Mr. Dilip Kulkarni, to take over with you for the question and answer sessions, whatever questions would be there in that one.
Thank you very much, Harold, for a very enlightening presentation on advanced NDT methods and what is the current situation in Africa. So from my side, actually have a question before we go on to the two questions we can see in the Q&A box. In your slide in changing your regulatory environment, you mentioned about SAQCC, competent person in pressure vessels area, and SAQCC, inspector of pressure vessels. What would be the fundamental difference between these two qualifications or certifications?
Fundamentally, we're looking at number one, the actual training that they provide. So in other words, they look at various aspects or different aspects of the actual inspection process. And then they're also looking at, for example, the experience that's required. So in other words, under IPE, you're going to get, for example, the same kind of training, but the exposure, for example, in the field to inspection of different types of vessels is mandatory. So in other words, while you've got the training to actually perform the inspection, the IPE, for example, requires additional experience on various vessels before you can actually apply for the certification process as well. Also, the certification is valid for a period of 3 years, and then you can renew it for 2 sessions. And then after a 9-year period, for example, you need to recertify again in each one of those certification options or certification schemes.
So if I understand it correctly, the inspector of pressure vessels is more of a experience based, or it requires more of actual experience in inspecting pressure vessels. Am I right?
The IPE normally, or the inspector of pressurized equipment, he's normally the individual, for example, that requires the additional experience, while the competent person actually is the person who's able to do the inspection, but does not necessarily have all of the required experience as such. One of the advantage, or one of the big focus points on there, for example, this certification scheme requires, for example, the inspection or the training of level 1 and level 2 welding and fabrication inspectors, and that is actually one of the largest training offering, for example, of the SIW. So in other words, there's roughly I think more than 6,000 welding inspectors for level 1 and close to 3,000 welding inspectors for level 2 that has been trained. So in other words, that is the feeding ground for example, towards these certification schemes.
Yeah, Chris, you wanted to say.
Dilip, can I just clarify something? Harold, is it not just as originally was? IPE is for new vessels, competent person is for vessel and service?
Correct. But even
What's the
then,
big
for example,
difference?
you're looking at the requirement, yes.
Okay, so let's just start with the questions which are there in the Q&A box. The first question we have is from Mr. Yogesh Kumar Sutar. The question is, how new NDE methods are used for non-ferrous material?
In non-ferrous materials, you're looking, for example, at composite materials, etc. So in other words, that is normally or very often more material that's actually being used in the aviation industries. And then also looking, for example, at some of the pressure vessels with regards to non-metallics. So what we've got under the IPE, one of the subsectors on an IPE is actually a non-metallic component, whereby similar training is provided, but only in the field of non-metallics. However, that is a very, very a new, a certification option. And I think currently in South Africa, we've got, I think, 9 or 10 people that's actually certified under the IPE for non-metallics. The actual SAQCC committee is actually looking at expanding that significantly under the leadership of a few personnel that's actually quite knowledgeable and skillful within the non-metallic environment.
The question was actually for non-ferrous materials. So you answered for non-metallic, but I guess between ferrous and non-ferrous, there shouldn't be much of a difference, except that the eddy current kind of testing could be, there could be limitations.
Sorry, sir, yes. And then also you're looking at, for example, on the on the radiographic testing as well. And there was a difference in the density of the materials as well. So in other words, there's a few material differences, but in general, the ferrous material will actually cater for most of the methods as well. Except like, for example, you've mentioned in eddy current testing where you require a conductive material as opposed to, not necessarily, for example, it must contain any ferrous component in there, yes.
Yeah. The next one is more to do with whether is this certification and course available online in India? That's from Sanjay Kumar Bhusai.
Just trying to clarify the question. So in other words, the certification option, is it available in India?
Yeah. So
I know that
whether you are offering it internationally, that may be a better way to put it.
Okay, certification schemes is normally in the domain of the ICNDT. So in other words, what they normally do is they approve, for example, certification bodies within each one of the countries, and then through a mutual recognition agreement, then, for example, they gain international accredit or recognition through that process. So in other words, while companies like, for example, PCN as well as CSWIP, they provide the certification schemes globally, the current SIW certification scheme is not expanded globally. So in other words, it's a very, very much a national scheme. We have tried, for example, within Africa to actually expand that into other African countries. But I must say that the countries in Africa is very patriotic. So in other words, they are very proud of having a certification body, our national certification body in each one of the actual countries itself. So in other words, that's now the process that we're trying to instill with them to actually develop a national NDT certification body for each one of the countries. Challenges arises from that in the form of qualification centers, and then, for example, for the infrastructure that's required for examinations as well. But that is being slowly but surely being addressed either through the ICNDT or the African Federation.
The next question is from Mr. Ishwaran Thangavale. It's about remote visual testing. So his question is, apart from visual observations, is there any sensor to touch and feel the object of testing?
The picture that I've actually shown you, that the Helios drone, that arm that you saw there, that's actually got a ultrasonic probe at the end thereof. So in other words, you can physically go close to the surface, and then, for example, there's a process of actually introducing a coupling to the surface, and then you can actually do ultrasonic wall thickness measurement using that drone. So in other words, there's a few contact options that you can actually utilize, keeping in mind that the stability of the drone and the ability of the actual pilot will greatly influence, for example, the results that you're going to achieve, because it's not always that easy, for example, to fly a drone and then touch it to a certain area and have reliable results as a result of thereof.
Right. And then we have a comment and a question from Mr. Ashok Mandal. Excellent presentation, Mr. Harold. has the ultrasonic phased array been employed for fillet weld tests and rail welds? So basically, it's talking, I think, about thermit welding, aluminothermic.
There is a few companies in South Africa that actually produces, and I was looking at, for example, Actom, but that's mostly with regards to the rail carriages. Rail itself, there has been attempts in the past to actually do the inspection. I think at this stage, there's only 1 or 2 dedicated companies with imported technology that actually provides that kind of service. So developed locally, not, but definitely imported from overseas, the actual technology itself.
Right. And then the next question is from Mr. Niranjan Bhandarkaute. In digital radiography, type of source remains same and only manual film processing is replaced, which is correct. It's only how the image is captured is the difference between a conventional radiography and a digital radiography, right?
Very much correct. And then also the ability to actually enhance the actual image that's being produced.
True.
So
true.
while you can get
once you have a digital file, you can do many digital computerized operations on them.
Correct. Yes.
Then you have a question from Mr. Anirban Datta. How advanced NDT is used in the newly built plant before commissioning is done, or maybe during commissioning stage?
Within the power generation industry, we had 2 new build projects. I think was starting roughly 2010. They were from the onset, normal conventional NET was done. And then as a result of the actual construction process, slowly but surely, for example, phased array testing of the actual welds in the boilers were conducted. And there were a few issues that was identified, and consequently they were also fixed. So the latest new build projects that we actually had was very much a learning trend with regards to introducing advanced techniques, and the advantage that was actually going through the process was quite significant. So in other words, hence the requirement of Eskom, for example, to rather consider phased array inspection of boiler tubes as opposed to only conventional radiographic testing to actually identify any problems within the actual tubes itself when being new built. Yes.
Right. And his next question, I believe you answered when you're answering the first one, because his question is any advanced NDT for non-metallic materials, which you answered right in the beginning when you talked about NDT for composites. So we'll take it as already answered. He has another question. Is there any advanced NDT method to evaluate the piping material quality under insulation without removing the insulation material and collecting the data while pipe is under service? That's tall. Yeah. What do you?
I know that ICFM has actually been utilized significantly with regards to trying to inspect on a cladding and without direct contact on the actual surface itself. And then, yeah, I would think that is the short answer for that question. ICFM has been used. There is also use of pulsed eddy current that can also be utilized in certain areas. I've played around with it, and it's not as clear cut, for example, and analysis of the actual results is quite difficult to actually have a constructive result emanating from that.
So in that context, what would be the POD and FCR? Probability of detection or false call rates? We are talking about inspecting something with the probe not being in direct contact, but having a mass of insulation material in between.
Depending on the ultimate liftoff of the actual, in other words, the distance that the probe is actually from the surface, that will influence the detection of the size of the actual fluids. itself. There was obviously the larger the floor, the better the detection capability would be. So it will depend on the type of floor, the orientation, and then also the physical volume of that floor, because that will ultimately influence the change in the magnetic field and then the consequent detection thereof. So it will very much depend on that. Personally, I have created, for example, a normal eddy current probe that is capable of actually inspecting for surface breaking cracks in a pulley with a lift of 10 millimeters in a rubber lining. So in other words, it just depends on what kind of focusing you're going to use, because ultimately the inspection medium is actually the magnetic field. So in other words, if you can strengthen the magnetic field on top or inside the material, then the ultimate response would be much greater, and consequently you could actually find in the floor. So, and that will depend then on the size of the floor that you're going to detect. False call rate and then also the probability of detection will be required. You will have to actually do some kind of a study in the specific applications, since the material properties will also have an influence on the result.
All right. We have another question. With the rapid adoption of AI-driven image analysis and phased array ultrasonic techniques in critical industries like aerospace and offshore, how do you foresee the balance between automated defect characterization and human interpretation evolving over the next decade, especially when it comes to liability, code compliance, and inspector competence?
At this stage, being very much in the infant stage, we are in the process of aligning the interpretation of the human interpretation with that's actually been obtained through the automated analysis or machine learning or AI. But so far, a few discrepancies has already arisen from those comparisons. I think at the speed at which these advancements is actually currently being made, I would think that within the next 5 to 10 years, while the intervention of an operator will still be required, I think the results that's going to be obtained from this system is going to be much more improved. So I think if you're looking at the global industry, the advances within technology, then within the next 10 years, I would still not anticipate it purely being digital, but I would think that the role that the operator is going to play in the whole process will be much reduced. Yes.
Right. The next question we have is from Mr. Vijay Kumar Shah. NDT certification for ISI. I suppose he means ISI is in-service inspection. Do you utilize real flaws or artificial flaws?
With regards to the training, we've actually got we've got mostly artificial flaws, and then also during the qualification exam, we've got artificial flaws. There is a few samples with regards to real flaws that's being introduced. So the limitation between artificial and real flaws has been identified. But then, for example, to create a test bank or a library of real flaws needs to be facilitated through a platform. And one of the ideas with regards to the Nuclear School of Excellence is actually to create an EPRI type facility within Africa that is actually going to be able to collect and collate all of these real flaw samples, and then utilize them as part of the reliability tests that needs to be done prior to actually going on site. In the power generation, for example, there's a few entities that actually collect these samples, but they've not been transferred over to a system that can actually control them and then utilize them in a formal way with regards to process evaluation.
Okay. The next question from the same person is, do you use NDT method for residual stress measurement required for structural integrity?
Yes, we do. but we do not have a national certification scheme for that. That's one of the reasons. Otherwise, you're looking at leak testing as well as thermographic testing that's not been included, for example, in the national certification program either. So in other words, we've got the 6 basic methods, and then also introducing, for example, time of flight and phased array, looking at eddy current on the tube inspection as well as surface, but looking at the other techniques, for example, chirography and those kind of things, the market is not big enough to make it a sustainable certification option.
Yeah, and we come to the last question in the question and answer box, which is from the person who asked about doing NDT on top of insulation. In reference to the question related to NDT for thermal insulation, what will be the effect of temperature on the results? So I guess you're talking about a live pipeline which is at a higher temperature.
In general, increased temperature will have an influence on both the conductivity of the material and also with regards to the magnetic properties of the materials. In other words, it will change it to a certain extent, and that will also have an influence ultimately on the actual response. That's apart from the physical limitations, for example, with regards to actually placing it close or near to the actual surface. So that should have an effect on it. If you're looking, for example, on normal eddy currents and those kind of things, that will also have a significant impact on the actual result that you're going to obtain, because purely of the how can I say, of the changes or the influence it's got on the conductivity of the material itself. So yes, there will be an effect. The extent of the effect that will have to be done through practical experimentation and see, for example, what the physical result is going to be.
So from what I understand, what you're saying is that you would have to experimentally develop the procedure and maybe establish the reference.
Yes.
Yeah. Okay. So with that, we come to an end to the questions and the question and answer box. And
Thank
if
you,
the
Mr.
panelists won't have any questions.
Thank you, Mr. Kulkarni, for conducting the panel and session, question and answer sessions as being a panelist. And thanks, Mr. Harold Jansen, for an excellent presentation and a wonderful deliberation for almost about 90 minutes. And people were very much fully involved in this one. Today, we had almost close to 60 participants who are registered, who have participated. And I thank all the participants who participated from India, overseas, I see somebody from Middle East, and some participation from Singapore is also there. And I thanks all of them for this one. I also thank Mr. Chris Malbon for coordinating all the wind program. Our next wind program is likely to be in the month of October. The details will be informed very shortly. We are working out on that one. So Harold Jansen, thank you very much for taking your time and valuable effort and then sharing your experiences with our Indian team. And I'm sure that in case of any of the members has any doubt, they will communicate with you directly in a mail so that you can reply to them properly. I also thank Mr. Ashok Malge, the chairman of the IIW Foundation, and Mr. Sachin Sorve for taking a lot of efforts in promoting this welding course and everything. Thank you, ladies and gentlemen, for participating in this wind program. With this, the recordings are available, and I think the recordings will be put on the link. And the people who wanted to download the link, they can download the link for it. Thank you. And
thank you, everyone.
Have a good day.
Thank you very much.
Thank you.
Harold?
Yes,
Yes,
Mr. Chris.
Mr.
Do you
Harold?
have anything? Mr. Chris, you have anything to say before I close up the session? Before I log off?
I thought it was great. You organised it very well. Our friends from IW India, very well done. And Harold did a great presentation. So I'm actually quite thrilled of another win success. I think it's been very, very good all round. And I think we've done a lot of good with spreading this knowledge around the world. So thanks, Harold, and thanks everyone to IW India. Well done.
Thank you. Thank you.
Thank you, sir. Thank you all.
Thank you. We are logging off now. Okay.
Thanks. Harold, while doing that, just tomorrow night, it's 12:30 in the morning, the Canadian one.
Yes.
So I might come in at the beginning to make sure there's no mess ups, because the very last one we held, the guy said he had computer problems, but it ended up everybody came in, the host wasn't there, so they all went away. And the speaker and myself were sitting there, you know, waiting and waiting for over half an hour. And in the end, there was one student, me, and the organizer and the speech presenter. So we did the whole thing, but it shouldn't happen tomorrow. There's a young lady called Danielle in charge. She's doing it. And it's just that I don't want to be staying up 1:30 in the morning, you know what I mean?
No problem.
So, but I think the recording from this will be very good as well, that we could use this one for the South African. I'm thinking the range of questions that came up.
Yes.
So what I'd like to suggest is I'll send an email around to everybody, to the group. And what we should probably do is I'll recommend, if you're happy with that we use the IW India recording.
Absolutely perfect. No, it's fine. If we've got permission from them to use it, it's no problem.
All right, that's great. Okay, just one little thing I want to ask you. The thing under insulation, if I go back 20 years ago, I had TWI out in Australia demonstrating their techniques, and they had the opposition, a university in London, and that was for doing, it was UT, but under insulation, you know, exactly what the question that chap asked. Is that still going? Do you know? I haven't really followed it, but are those techniques still being used?
We've got the EMAT system. It is being used. I know, for example, at Kuburg that they're utilizing, for example, the ACFMA or ACFM inspection. The EMATs on a greater scale, I must look at the local industry to see, for example, what the usage is. I know that they actually do to identify, for example, on boiler tubes that they use that, but I must have to actually.
I'm thinking specifically of the TWI method, though.
Yeah.
There was an ultrasonic method because I brought them to Australia doing demonstrations around the country with all the big pipelines we have in Australia. And I even had demonstrations on in fact, somebody came from South Africa. The agent in South Africa, Willie Rankin, it was Willie Rankin, you know. He came out to Australia to the demonstration. We ran an international conference and we had the practical demonstrations on BP, the British Petroleum, their site in Brisbane. We actually had all the delegates out on the site having these NDT demonstrations. And I often wondered how the TWI one had gone, whether it had really taken the world by storm. But the rival was a university in London. Does that not ring a bell?
Are you referring to the GUL system? In other words, the guy that weighs ultrasonics.
The GUL. That's right.
That one, yes. I know at some stage they also did a presentation at SRW, I think it was roughly 5 years ago. There was a few experiments that was actually performed at Kuburg. At that stage, he was still, I think Mark Digby was still asking for that. There was results, positive results on it, but to the extent that they actually wanted to detect the flaws underneath or the size of the flaws, it was not very, very successful in actually identifying that. So it's not been rolled out commercially, especially at Kuburg, for example. Other places might, and then also at Petrochemical, I think that they have also utilized the GUL system extensively there because of your underground, for example, piping, so that they don't need to excavate to actually find the flaws in that instance.
It was the petrochem industry in particular that we were exploring. You know, I say BP, the refineries, and then of course the oil pipelines coming from, say, Central Australia going out to the coast. Yeah. Okay, I think they might be waiting to close off. Ashok, are you waiting for us to go? He's on mute. We can't hear him. But anyway, I think he's talking to us. He's doing what I did last night, was it? I think we're still on mute when I was talking. All right. The other quick question, and well, that's IPE and competent persons. they haven't changed it because the IPE, I actually set them up, don't forget. The IPE was only for new components. The competent person was really in service, you know? Is that still the same?
They have changed the syllabus beginning of last year. They have changed, and they've combined, for example, all of the limited and the unlimited, for example, and the CP for pressure vessels, for example, into a single component. I will have a look at what the content thereof is. But currently, for example, if you're looking at the certification process and those kind of things, you're looking at, for example, experience required, for example, for the IPE, no training required for that, because you've got already, there's other components of the actual training process that is required for IPE, but there's not a specific IPE training per se. You've got the CP training, for example, to actually get that certification up and running. I'll just check on.
But for the IPE, what I use, you remember back in the 1980s, I brought the National Board of Boil and Pressure Vessel Inspectors to us, South Africa. And every year for about 9 years, we ran 2 weeks of courses. And then it still carried on after I went. And then they used that as the model for the IPE training, you know, to build up. And in fact, on that IPE, I was a stickler because I actually even had it where we had people would put in their applications, and if we were suspicious in any way, and I was always suspicious, we used to go to the company to audit the files. You know, when someone said, here's this company, because a lot of it was on experience. And of course, the bosses would build up that experience, you know, because they want to get their guys certified so they can get on the job. But I used to force the issue that we would go out and inspect the files on those people. And it was good, actually, because it made the bosses wake up that you couldn't get away with fiddles, you know? The other question I was going to ask you, are you able to send me a digital copy of 9712, the latest copy?
I will send you a 9712.
Yeah, I know. Look, it won't go anywhere because it's just I want to go through it. Some of the paragraphs I'd used in the guidance note from the previous one, 2012.
Yes.
I want to basically go through and make sure I'm not talking nonsense. And then once I've got that draft done, remember about the reviewers, you know, you and I, you'd be a reviewer. And then at the moment, I've written to the different organizations like ASNT and so on saying, look, I've been on your website and I've taken this information off. Do you have any other information, like a needs analysis or something? But the reviewers, I'm going to be, like we said earlier, when you and I helped, you gave me some names, try and get a diverse spread of them across the world.
Okay.
You know?
Just by and by, if you're looking on the ICNDT website, under the ICEC, you will see that they've got quite an extensive list of standards, specifically with regards to ISO, EN, I think ISO and EN in there. So there's a very, very useful source of information for should you require.
I've been right through the ICNDT website. You got to remember, look, we set up with IW 2012 when I did that keynote in Durban. The key thrust in that was the IW and ICNDT should be really joining forces, working together. Then I worked on the MOU, and in 2017 in China, we agreed it was all signed up. And I think last October, IW and ICND have signed it again. So they've renewed it. I'm not sure how far it was going, though, to be honest. You know, sometimes you need to push these things. But anyway, they've re-signed it now, and Luke is supposed to be driving it. So you're right, ICNDT, Babu. See, David Barnett, the guy before Babu, he lives not too far from me here in Australia.
Okay.
I've known him for years, David. He was the secretary before Babu. And I know Babu as well. For years, you know. So the ICNDT, it's a good site. I enjoyed looking through it, except they're not showing the latest strategic plan. They showed the one from 2014 or 18, but I wrote to them and to David Gilbert and Bin saying, hey, can I have your latest one? And they said, oh, we don't publicize that anymore. I said, it doesn't matter. I'd like to put it into the guidance note or the link anyway. But they said, no, they only give it to members, which I don't know.
Okay.
It seems to be a change of. Anyway, look, we better go. I'm not sure whether we're holding everybody up. Ashok, are we holding you all up?
No. I'm just enjoying the thing, and it was fantastic. And Mr. Harold had a doubt whether the presentation will go smooth or not. So we had downloaded, we had made alternate plans. If anything goes wrong, we'll push from our end. And in Mumbai, because of heavy rains last 4 days, we were thinking that whether internet is going to be constantly working. So we had made arrangements from Calcutta even, our headquarters.
Thank you
So
very much.
everything went smooth without any problem. I don't know what was the issue yesterday, really.
Excellent.
Thank you very, very much, sir.
Yeah. We had 4 alternative plans. If anything fails, other will take over.
Excellent.
Mr. Basu joined from Kolkata also.
Yeah.
He's
You mentioned.
system.
Sorry.
Yeah, Kolkata.
You mentioned.
Kolkata 2 places and Mumbai 3 places.
Ashok, you mentioned we had 59 people.
Yeah.
That's about 30% turned up. Obviously, with the storms, as Sir Surini said at the beginning, with the storms and everything else, you get people not being able to get into work and obviously use the facility there and so on. So maybe we're happy with 60. I was hoping to get 100.
Yeah. Now, today in Mumbai, especially from Mumbai side, everything has come to standstill because local transport has failed because of the heavy rains, clogging of the roads and railway tracks. So the internet issue is also there because of some fluctuations. People may not join. Otherwise, I was expecting around 80 to 90 people to join total.
Yeah.
Anyway, 60 under these circumstances, 60 itself is fair enough. Not bad.
Well, yeah, the main thing is they'll have the recording anyway. The people who couldn't make it,
we'll do that.
they'll have the recording anyway, which is good.
We'll do that.
Okay. Look,
Okay.
I'll finish there then. Ashok, thank you very much. I
Thank you.
appreciate all your help, eh?
Thank you very much.
Thank you, sir.
Thank you, Harold.
Bye.
Harold, I might come in just before
Bye-bye.
midnight tomorrow night, okay?
Yeah.
If I don't,
Thank
you know
you.
I've got to sleep.
Yeah.
Fine. Excellent.
Cheers.
Go well, everybody.
Well done, Harold. Keep well. Cheers.
Thanks. You too.
Thank you.